Okay, hello everybody. This is the third session of the basics track, software development metrics that you can count on. Arthur Hicken, who is also our tutorial chair for this year's conference, will speak at this time. And what can we say about Arthur? As evangelist for Purisoft, he's also one of our sponsors. Arthur Hicken works closely with the company's upper management in making strategic decisions. He has been involved in automating various software development practices at Purisoft for over 20 years. He has worked on projects including database development, the software development lifecycle, web publishing and monitoring, software build automation, and security. In addition, Hicken, or Arthur as we like to call him, has worked with the IT departments in companies such as Cisco, Vanguard, and Lockheed to help improve their software development practices. He has developed and conducted numerous technical training courses. Again, he is part of the conference committee, he does tutorials, so we're very appreciative that he is also able to speak as part of our track. And with that, I'm handing it over now.
Thanks, I'm glad everybody could make it, and I'm glad we have a nice full room. It's going to be a lot of fun that way. Like you mentioned, I've been doing this for quite a while, and the company I work at, we've always focused on various forms of automation and quality improvement. And so when you do automation and quality improvement, you must of necessity bump into metrics at some point. Because without measurement, there's no way to know if you had improvement. So I have kind of this love-hate relationship with metrics. I talked about it at lunch a little bit, but on one hand, a lot of metrics are misleading. A lot of times people pick the wrong ones. They're confusing. They don't mean what they think they mean. And so it's easy to reject metrics. And that's what we see is people tend to go, oh, I don't like metrics because I had this situation. It's really their lack of education or proper setup to get it done right. So on one hand, I hate them because they can be misused. On the other hand, I don't believe you can actually progress without them. And so I wanted to talk about some of the things that will help you identify dangerous metrics, just a couple of examples of when some metrics are dangerous, and learn how to use them more effectively. If you came here for a silver bullet, I'll just tell you that there isn't one. Okay, so you can leave if you. Why should I care about metrics? What is the point? And this is, I think, where people run off track, and I see this. Sometimes people are doing metrics for metrics' sake, and if you're deep down in the organization and your manager said, I need metrics, then okay, I guess that makes sense, right? But if you're actually trying to manage your quality, then you need to figure out why am I doing it. And I think one of the most interesting metrics is what is my quality? Can I measure it? Can I put a number on it? We'll talk about that in a minute, but let that percolate through your brain. We could argue that probably for the next 60 minutes, right? We get people going on that one, it's fun. But what is my risk? Right? Where is my risk? Not just what if I have risk, but where is it? How can I go track it down and make it go away? Is it good enough? Can I ship it, right? Can I put it out? Can I put this in unsuspecting customers' hands? Matt, was it you and I that talked about Google's testing process?
Yeah.
Right? How many here have ever used a Google product? How many have experienced a bug in a Google product? And how many have officially reported to Google that bug? 2, and how many have gotten a response in terms of a bug fix or at least a nice mail that acknowledged what? And the answer is 0, right? So they may or may not know, is it good enough? On one hand, I might say, well, they obviously know because they're in business and the products are out there and they're generally working. On the other hand, maybe they don't know at all and they just ship it and let it sort itself out and fix things. So it's an interesting question. And is it done? And in this age where people are trying to move toward a more agile, more extreme, more frequent release cycle, continuous testing, continuous release, the holy grail, continuous deployment. I code, I hit a button, and build, test, deploy, and it's live, right? That's a great thing to do, but I have to first be able to quantify, am I done, right? So these are all interesting things that metrics can help you answer. I thought this was funny to pull up the definition of metrics, and I'll leave this for you all to read in long later when you pull the slides down. But basically we're trying to quantify things in a scientific way, meaning we're not just pulling numbers out of the air and deciding this has this meaning, that has that meaning, but trying to figure out what's going on by observing and measuring. And the problem is that in the software industry, there are a few metrics that are well researched, and there's a lot of metrics that are semi-well researched, and there's a lot of stuff that are just numbers out there, and we all play with them and we all use them. But overall, the software industry is seriously lacking in a lot of standard engineering things that exist in other practices. And so one of those obvious things is the ability to measure, control, quantify what we're doing. And it becomes a real problem. So it's one of those things that we look at and try to figure out how can we move it forward. And that's the fun thing. So, you know, Stuart threw out my title evangelist, and that's a funny one that we can also have good conversations about. But the idea is I do a lot of different things, but overall, I work with various groups across industry trying to move the state of the art forward. And so for me, metrics are important, not just can I use them to improve my quality, but how can we as an industry produce better metrics that are more useful that will move everybody forward. Because guess what, I also consume software, and so if I can get Google to produce a better browser, it'll benefit me, because I lost 30 minutes today fighting with Google, which I did figure out, by the way. It's really bizarre.
Did you report it?
So, I haven't, and I thought about it, and then I looked at some of the other Google reports on the same issue and saw that there was, I don't believe that I had a chance in hell of getting an answer, so I didn't bother. I haven't experienced reporting a bug to Google, and I'm kind of retentive, so I created a test case with sample data against their API that shows working code, bad code, here's what happens, here's what fails. And Google told me, well, you need to read the docs. So,
I actually had a case where I called Amazon on an issue with the iOS Amazon video player. I got somebody, they responded, and they corrected my issue. That's equivalent to getting a response from Google.
Right. It's a very interesting thing, because on the other hand, I had a VMware issue, and let me tell you that at the time that I had it, we had like 4 licenses. So to a multi-billion-dollar company like VMware, I'm not even a gnat.
I got someone on the phone. I actually called and got a support engineer
I called
on the
VMware.
phone.
They asked me to send the problem in. I quantify. Again, I lay it out. I've got screen captures. I've got exact steps. Here's how to reproduce the problem. Here's the symptom. You'll see this path always produces it. This path sometimes produces it. Here's my hardware, the OS, the hardware, the version. Because I worked in the other side of the business, I know. So I give them this great report. Nothing. Like 3 weeks. I'm gone. I'm moving on. I don't even. I'm like, okay, they didn't respond. I'm done. Then I get a phone call, we fixed it. Do you want the beta or do you want to wait for the general release? I'm like, okay, grade them low on responsiveness, but very high on actually fixing the damn bug. So this is just a bunch of common metrics. We could list forever the kinds of things, but one of the questions that came up at lunchtime were, what are the metrics that people are commonly using? And these are the ones that I bump into the most frequently when I'm working with our customers. That's probably a slanted base at some point, but we do deal with a lot of compliance industries, automotive, aerospace, FDA, things like that, and they tend to be far more rigorous around metrics, sometimes doing metrics for metrics' sake. And then, we also deal with, pure internet companies that produce software that can change in 15 minutes from code to actual deployment. And they tend to be less rigorous. One would think that they'd be more rigorous being that fast, but it's not that way. So these bunch of interesting metrics, and one of the questions that comes up also is, what are the metrics and which ones should I use? And we'll talk about that a little more as we go, but I believe the metrics are relevant to your business needs. I don't think that there's necessarily metrics that are perfect for everybody. There's a few that we can all benefit from, and we'll go through some of those as we go, but I don't think that, sure.
Sort of my learn a new English word for the day. What's connascent?
I don't even remember that one. Sorry.
Okay.
We'll look it up. Someone can Google it, and we'll have an answer. One of the interesting things about software metrics is that a bunch have kind of taken on a life of their own, and so now complexity has a meaning in the English language, but when software people talk complexity, they generally mean decayed complexity or cyclomatic complexity. And so it's weird. It's like the complexity with a capital C, right? Or all caps or something like that. And cohesion and coupling and KLSC. So there's some very interesting metrics which kind of indicates that become very popular. Some of them have a lot of research behind them. Some of them have a lot of industry-written papers by people who sell such products. And we'll talk about snake oil in a minute, if that gives you an idea what I think. But my basic thing is that there are no silver bullets. There's no single metric. There's no number that you can lay on your software that says it's perfect, it's done, it's safe, it's ready, whatever. There is no single metric that's going to do this, that's going to say this software is bad, this software is good. We have to have a much more nuanced approach to what we're doing. And one of the other danger areas I wanted to point out that metrics can quickly lead you into a trap of doing averages. And as I put up at the top, averages aren't normal, right? Averages frequently are a number that doesn't represent any data in the data set. There is no point that actually hits the average. And so we see here we have an average depth of 3 feet in the drowning man, right? So averages can be useful to help us understand things, but if we think the average gives us a value, we have to be careful. And I think the most dangerous area I see averages getting bound up is in performance. I had an FDA customer who was measuring their system, and they were measuring performance time based on putting the query in and getting the answer back in the system. And it's a customer-facing system, so real people like us are going there and checking prescriptions and things. And their average performance time had increased, but it went from, I don't know, 100 milliseconds to 200 milliseconds or something. Who cares, right? It's less than a second. Humans don't care about seconds. But it turned out when we looked at the data, that average should have been concerning because, not because of the number itself, the average, but because the average doubled, right? And when we looked at the data, what we found out was that it turns out all requests aren't equal. They weren't coming 200, 200, 200, 200. They were coming 100, 100, 100, 10,000. 100, 100, 100, 100, 10,000. And that was scary. And that was a case where if they looked only at the average, which the DevOps team was doing, the ops guys were like, it's still well within the SLA, but potential risk for something responding 1,000 times slower than it should be occasionally, relatively dangerous. What would they? So be careful with averages. So this is, sometimes I do a thing just about, I have a whole thing about can you measure quality, right? And I have these conversations with people, and it's a lot of fun, and you can argue with people all day long. And if you look, if you follow me on LinkedIn, you'll see some of these conversations occurring on LinkedIn and places like that. Can you measure quality, right? And one answer, no, you can't. You can't quantify quality. I can't say that our software quality is 14 and Google's is 7. What the hell is that number? On the other hand, you can measure things that are important. I don't believe there is a quality number. I believe that you can internally define for you what quality means. And quality might mean uptime, it might mean performance, it might mean number of field bugs, number of user complaints, it might be sales going up, repeat sales going up. You can quantify the effect of your quality and see if it's going up or down. So I think that you can do it, but I don't think there is a number, right? And we're going to look at a couple of funny numbers and single metrics and the way people have abused them in the real world. All real stuff. So what can you actually measure, despite the weird metrics that I showed earlier? Code churn is an interesting metric to me. Code churn means that I edit a file, I make a change, I commit it to the system, and then I do it again, and I do it again, and I do it again, and I do it again. And again, by itself, it may not mean anything. It might just be that we got a little change going on. On the other hand, if it's out of whack with the average, why is one part of the code churning more than others? Is it more error prone? Well, if I look at the field bugs and I see that it's error prone, code churn led me to something. So I think code churn is relatively interesting. It should be normalized. You should be able to see an average, you should see typical behavior, and you should see anomalies, and it should tell you something. I believe field bugs is a metric that people don't pay enough attention to. It frequently belongs to the QA department, and they manage it and they close it out. But I think it's a great indicator of how well you're doing. It may or may not mean your customers are happy or unhappy, which is a separate metric and you have to measure it. But certainly, all other things being equal, I'd rather have less field problems than more, right? And again, like the Google thing, if Google knew what all of us know collectively about their browser, and we probably have a bunch of good test cases, they'd be better off, right? A lot better off. Static analysis findings are interesting, and I talk a lot about static analysis with people. There's a lot of interesting things you can do with it. I think that static analysis in many, many cases isn't so good as a bug detector as it is as a variable in a larger equation to help you decide, am I done, is it good, is it risky, things like that. Test failures is another one internally. I'm talking about the QA department, and not just the automated tests, but the manual tests. What tests are being run? Are they failing? Are they failing regularly? Are they failing irregularly? Do I have a test that succeeded for 10 years and is now always failing? What functionality did I just lose? Did I just break? You know, things like that. So I think looking, and I think a histogram of test failures is very interesting again, because we unfortunately all kind of learned to live with a certain level of noise. That we ship software and it's got a number, a metric that we're comfortable with. Years and years ago, my brother used to work at the same company as I, and he wrote our first unit test framework and counted, we had 500 tests or whatever, and he did a quick percentage at the end, right? Collect the pass fail, at the end throw a score, throw a percentage, and he did a really funny thing, right? It's like 50% is like 50% failure, fire the developer, right? 70% failure, send it back and do it again, right? 80% failure, ship it, right? But the funny thing is that software development, what's the most important metric that most companies use to determine when to release software? It's an actual question. Date. It is date. God help us, it should not be date. In Google's defense, date is not a metric that Google ever uses to release software.
But I just wanted to say that test failures might not be as useful as you're presenting here, just because after you've automated a test, most of the times it fails due to a test bug or a dependency failure of some kind. Not actually a process bug.
That's what I'm saying, is that there's a level of noise in tests that we accept, and it's actually working for us. So to falsely take a number and say, oh, all tests should pass, might be a really bad business decision. Right now, shipping just because of the date and half the tests are failing is probably also a very bad business decision. But I think you can balance it, and again, what's interesting to me is not even if it is 50. If it's 50 and I'm productive and I'm shipping and I'm not blowing the field up, and I've been doing it for years, it might be good to make that number up, but it's that number changing. If that number suddenly shoots from 50 to 70, I'm concerned. Simultaneously, if that number jumps from 50 to 20, I'm also concerned, right? I never trust big change. And that's why histograms and all these metrics are so interesting, especially when you lay them on top of each other, because typically, when you see this number drop, you see this number drop at the same time. Right? You go, oh yeah, less tests failed because we covered a lot less code, right? So it's a very interesting thing to start to see numbers. Performance, again, a classic thing. Make your software do certain things, known things, fixed things that will survive version changes if possible, and see how long it takes to do it. Make sure that you're not accidentally blowing something up. We created a runtime Java instrumentation tool years ago, and it would measure things like, how many times do you open a file in one application? And we created a rule, a simple metric. We pulled it literally out of the air and said, don't open the file more than 10 times. Completely arbitrary, no research, just made it up. Ran it on Eclipse, and we found out that during the opening of Eclipse, from click to it's up and ready to use, which is like 45 seconds or whatever, the same file opened and closed 500 times. So we thought, okay, this is a silly arbitrary metric, but we can measure it, why not? Found out that, you know what, it actually pointed to a real problem in the code. So it's interesting how performance can lead if you can measure consistency with it. Counts are interesting. There's an IEEE study, and it's in the notes for this slide. There's 2 different studies, so if you pull the slides down or remind me, that large files have an extremely strong correlation to the probability of having defects in a particular file. And if you think about it, it's not such an unreasonable expectation, because well-designed software tends not to be one giant monolithic thing that does 17 different things under the sun. So it's pretty interesting. Bug arrival rates, right? Again, and this is the number. I can't say my number's good, your number's bad, your number's okay. But if you look at how are you finding bugs, how frequently, how many come in post-release, et cetera. If one release you have 10 bugs in the first 48 hours, and the next release you have 100 in the first 48 hours, you screwed something up, right? And that should be a, how come we thought that was ready? Which of these metrics are associated with that? Or are we missing a metric? How come we didn't know? That number should be roughly consistent. You should always have a reason. One of the challenges in this, and it's different in different areas, but the varied tool chain that we see in big companies, and the bigger the company gets, the more varied the tool chain gets, right? Companies that grow through acquisition typically acquire a new workflow, a new process, a new set of tools, a new set of licenses to pay for. And it's difficult to try and make sure when you're using metrics to make sure that you're actually getting the same number from every team in the same way. I'll give you a really simple one, lines of code. I have had numerous arguments over the last 20 years about what is a line of code. Okay? Do you count white space, right? Do you count multiple statements on a line as a single line or one line per statement? If a statement takes multiple lines, does it become a single line? Do we count comments? Do we not count comments? We can argue these things ad nauseum. And I don't believe any of the answers is universally right. I think the only answer that matters is do it the same damn way every time. That's all I'm saying. And I guarantee you, if you're counting lines of code in different teams using different tools, you are getting apples and oranges, right? You are definitely getting apples and oranges. And open source. So a lot of times people have some open source going on in some groups and some proprietary tools going on in other groups. Again, making sure that you're getting the same kinds of answers and a uniform outcome. And we'll talk about some ways to get a hold of that in just a second. But one of them is mapping the tools. And it depends on what the tools are doing, right? If I have a tool that I know is counting comments, and I have another tool and I know doesn't count comments, and I really want not comments, I can probably create something that'll pull it out of the other if I have to. It'd be nice to get the same tool if I can, but if I can't, usually I can map things. Sometimes I have coverage that doesn't map the same way, and I can create. The idea is to find some common ground between tools. It gets really tricky in areas like static analysis, because if you take something like buffer overflow, one vendor will say this is a buffer overflow, another will say that's an overflow, and they're two completely different things. And they're both right, but they don't have the same definition. There's some tools out there that kind of do this. The DHS has funded a project from Secure Decisions, and they're trying to map all static analysis security rules to a common core so that Parasoft number 17 is equal to Coverity number 2 is equal to Clockworks number 4, so that you get a normalized set of results. And like I said, I think this kind of behavior is really good. There's a lot of issues in doing it in certain areas, but as much as you can, trying to get your results to an area where they have a meaning if you can't change the tooling. Get the results in one place. Okay, here's my best, probably my very best true life metric story. I'm at a bank, not in this country, so don't worry, it's not your money. If anybody's from Canada, take your money out of the bank. And they have a policy that says thou shalt not release code that doesn't have at least 80% code coverage. That's a pretty aggressive policy, okay? If you've been doing it for years, it's not, but if you haven't been doing it, that's a pretty aggressive target to go after. So I've got a room of managers and developers together, and we're talking about ways, because we're doing an automated test generation tool for them. And I'm going, so are we achieving this goal? When somebody tells me I have a metric that we're going to use as a gate in our software, I start with, Are we near it? Are we close to it? Where are we at? Oh yeah, we get it all the time. Okay, that's interesting. Then later, I always do this, split the managers from the guys doing the work. How many people, how many people are getting to 80% coverage? No hands go up. 70, 60, 50, 40. When I get into the 30s, I start getting hands. Start.
You have a more basic question. Define code coverage.
Yeah. You have to work from presumption at that level that I've executed a line of code, and it might be MCDC, it might be function points, it might be friend. Presume they have in their policy some definite, I don't remember what it
You
was.
know what they say about assume?
Yeah.
Make sure that the terminology you're using is agreed upon.
Yeah, I'll talk about coverage in a minute. But the point is that they had a number, and each team, each developer would measure his using whatever tool they had, report it to their manager, who would go 17, 17, 19, 14, average is 17, 20, because we rounded up. And he turned his 20, and his 23, and his 22, and his 24, and the average was 23, and we rounded up to 25 at the next level. And they were literally rounding them ways from the mid-30s to 80 at the corporate level. It went through like 8 layers, and each one added 5%. And shocking, right? Manual collection of metrics.
Don't tell me the name of the bank.
Yeah. Are you from Canada? Oh, you're in trouble because there's only 2 banks in Canada, and it's one of them. I'm not going to tell you whether it's 2 initials or 4, but it's one of them. Okay. You got to get the results in one place. They got to be automated and consistent, or they're meaningless. Okay, they're just meaningless. Reports have to be combined results. You can't trust people. By the way, the company was losing. I calculated it. Between that and other metrics, they were losing something about 25 or 30 man-hours per developer per month. If you're calculating your metrics by hand, figure out why and stop it. Okay, so, and then backfilling capabilities if you're missing a metric in some groups. I also think that the display of metrics is very interesting. And years ago, when we first started trying to really quantify our software development process, as opposed to the quality, we created this fancy graph, and I used it earlier. There's like 9 little charts on it. There were 9 different practices going on in your software. And customers always say, well, what does it mean? And like, people who are experienced will come in, well, if this graph is up and this is down and this one's going sideways, it means blah, blah, blah. And if this one's also going down, then it means blah, blah, blah. And if that one's going down and that one's going up and that one's also going down, then it means blah, blah, blah. Obviously, wrong presentation. It was really graphical presentation, but still raw data. Just because we made pictures of it didn't mean it wasn't raw, right? We fell into that trap. So I think the important thing about graphics are that they should have some meaning. And I've had this argument with people so many times, but my boss in particular likes to use pyramids. You use a pyramid when there's a reason for a pyramid, that somehow the top should be smaller and less frequent than the bottom, right? You don't use a pyramid shape and in it you put 40%, 20%, 30%, 70%. Doesn't have meaning. So I think that the graphics should quickly convey the answer to the problem you have. So there's a lot of things. Gauges. Gauges are cool, right? Because you get a quick answer on a single item or a multiple set of items. This is gauge my coverage, this is my failure rate. You can use little metrics inside there, you know, thresholds, ship it, don't ship it, fire somebody, you know, those kinds of things. Counters are very useful. I don't like, generally speaking, just throwing numbers up, because what I find is, well, if that number's up and that number's down, then it means blah, blah, blah. If that number's up and that number's up, it means blah, blah, blah. Well, then show me blah, blah, blah. Right? Don't show me a number that doesn't have a meaning. So percentages of test failure rates can be interesting. Numbers of test failures may or may not be interesting, depending on your organization. Number might be too high to have meaning. Humans don't do very well with big numbers, right? We lose meaning quickly when we can't visualize what that number is. We can all think of what 100 is. 1,000 gets flaky, and millions of whatever, right? It's a fake number, right? There's no meaning at all. I've recently become a big fan of the radar graph or SPIDAR graph. We did some really cool thing the other day where we're doing security testing, and using the data from the US government, you can break down security vulnerabilities based on what kind of problem they're likely to cause. So this can lead to loss of data, this can lead to unintended access, this can lead to privacy issues, this can lead to denial of service. And so suddenly we have this one axis, right, one dimension in our graphics. We have a count of each violation and its type, and we have a severity. This is critical, this is high, this is medium. You put it in something like this, and I go, well, here's denial of service, here's loss of privacy, red ones are critical, blue ones are medium, and I can lay down all kinds of interesting things on one graphic. So it takes a second to learn to read it, but only a second or two, and then boom, you've got some very complex information.
One thing, seeing the radar spider graphs in talks and things, and one of them is, how does one know what permutation to use, that the order that you go around the circle matters, because you could have one permutation and something that hits you right in the eye, and if you permute it the other way, it doesn't tell you a thing.
Yeah, and I think that's where you're supposed to think about, why do I have this metric? What's it supposed to mean to me? And will I get upset if this metric goes up? Will I get upset if it goes down? Will I get upset if it goes out of whack against this other metric? And make sure that it's showing it. And frequently what we see, I was analyzing the competitors' security dashboards, and they had 3 main dashboards, and what I realized was that in each dashboard, there was 3 metrics that were the exact same number in a different presentation. And I couldn't figure out why. Some cases I can though. I have cases where I'll put this number under this so that I get out, I'm good, I'm bad, and here's where I'm at. Because here's where I'm at might be important. If it's not, I try to leave it out. So yeah, there's a lot of thought, and there's some great books. I don't remember the name. There's an author that gets all into UI and usability. Maybe somebody knows off the top of their head. If not, I've got like 6 books on my desk at home. Remind me, I'll send you a thing. But I think it's important, if you're going to gather metrics, you need to report them up to somebody, and you need to present them in a way that's useful. Excel spreadsheet full of numbers isn't that way, because someone else is going to do this work. And if they don't understand the metrics you've gathered and what their meaning is, they will create some graphic that is probably at best useless and at worst misleading, right? Once upon a time, I was working with our sales department, and we had 2 lead sources, right? And one of them had a very high probability the number was just crap. Not there, wrong person, dead person, whatever. Terrible percentage of crap, like 50% of the numbers were just wrong. But like 20% of the numbers were sales. The other one, like 2% were sales, but 100% of the numbers were right. Guess which metric the salespeople liked? Right number, right number, right number, right number. And had we looked at the quality of the lead sources against right number, we would have done ourselves a huge disservice. Very important to have the number that's the thing you care about, right? Lots of kinds of graphs. It's worth researching different kinds of graphics when you're trying to present your data, and not just stick with, hey, I've been using bars and lines and pies my whole life. There's some pretty cool stuff out there that you can really use. And even like in Excel, there's some really great new components now that you can quickly and easily use. This is just a sample report. See it again, what I talked about. I put a graphic, I have a number, I have an up or a down, am I going up, am I going down? There's a little tiny percentage, how much I've been up and down. Those kinds of things that give you clues toward what you want to do. So how do you check, how do I know I have the right number? The answer is it going in the right direction, right? Again, I had a customer who was having hardware failures in the field. They get the Microsoft reports, right? You get the blue screen of that, and you click, tell that person to go to hell, right? And they send an email to Microsoft, and Microsoft sends it to the manufacturer. Number was too high. Okay, and that's a reasonable thing, you can say that. They bought a tool, they use it religiously, guess what happened to the number? Went up. Process they put in place had nothing to do with the problem they were working on, or the thing they were measuring had nothing to do with the actual problem. So when you start figuring out some numbers, start paying attention, try to tweak them, try to permute. Can we make this statistic better? No. Can we make it worse? I know that sounds crazy, but sometimes you can't make it better because it's hard. But you know for sure if If you can't make it worse and you can't make it better, it's not the number you think it is. Okay, so that's a way to check the number. Are you measuring enough? Again, if I release software and suddenly my number of field bugs jumps up and everything else is fine, I'm probably missing something, right? Either I didn't actually measure one of my metrics and pay attention, but if I did, it's quite possible that I did. It's quite possible I did everything I've always done, and I'm missing something.
Nyquist theory, gotta have a high enough sample rate.
Yeah. Are the measurements automatic? Again, humans are really bad at doing repetitive tasks and doing them right. The smarter the human is, the worse they are at that, okay? So if you want to hire somebody who will do measurements for you and do them properly, hire somebody who's, autistic, right? Because they'll focus on the stupid number, right? But don't hire, a PhD candidate and expect them to do something like this, because they'll do a terrible job and you'll think they don't know what math is. Might be right if they're a physicist. Sorry, Parasoft was founded by like 5 physicists, PhDs from Caltech, and they don't necessarily know what math is the way that we do. Consistency is the key to getting value, right? You got to, like I said, with lines of code, you got to get the same number in the same way every time. You got to have automation so you're measuring it the same way, that you're getting it all the time. And you should start tweaking based on feedback loops. Hey, the product was good, the product was worse, it was better. Can we start moving some of these numbers and start driving them up and down? Doing the same thing should yield the same result, right? I know that sounds crazy. Let's just quickly go over. One of the basic concepts I like to talk about is, we moved into this big data era in lots and lots of ways, certainly for spying on us, whether we're Google or Apple or Microsoft or NSA. We've gotten really, really good at gathering disparate data and putting it together and to find some new meaning. In the software development world, we still manage all this data in silos. So the trick is get it all into one place. Central repository, it can be a database, it can be a NoSQL solution, it can be get the data into a place and start analyzing it for the more useful metrics. You need to get some kind of central hub that you can report to, be able to get real-time feedback, aggregate the data together, right? And there's there's commercial tools, there's open source tools. I'll give you a caution. A lot of people, anybody here familiar with Jenkins? Jenkins has lots of cool little reports in them, but none of them had anything to do with each other, right? It has the illusion of information, but it's raw data. Okay, so get something that moves you past that. If you're not there, start with that, right? Get some histograms so you at least know on a single axis. But start combining the data, right? And correlate the data, mine the data, reports, dashboards, tasks, alerts, et cetera. I mean, I think it's very interesting. Some pieces of data, Matt and I talked about this earlier, sometimes a piece of data is good for management. We're okay to ship, we're not okay to ship, we're behind schedule, our quality's falling. Sometimes a piece of data tells you need to do something else, like, oh, we changed a piece of code here, we had a field bug, and that means we need to retest these 17 different tests. So sometimes there's actions created off of the aggregation and harnessing of data. So it can be very interesting. I think we've talked about that. Let's talk real quick about some trips and traps. And I think I've hammered this to death during lunch and before lunch today, but sometimes the names are misleading, right? The software complexity isn't necessarily complex. I think the picture in this one, I added a picture. I apologize for if you download the slides, let me know I added 2 slides. So this is a piece of software that isn't complicated, okay? Simple code, anybody can work on it. Probably easy if there's a bug, it probably jumps out at me. This one isn't, okay? So the trick is that there's a school of thought that says complicated software is more difficult to maintain and more likely to fail. The problem is that cyclomatic complexity metrics appear to show no correlation to those. And when developers look, or little, some people disagree, but when developers look at a cyclomatic score, they frequently get a number that indicates that, but shows that when you look at it. So be careful of the metric you have and make sure it correlates to what you're looking for. I've got some interesting ideas about that, but they're not in the scope of what we're doing. Lines of code, we talked about how be really careful. It's useful, but be really careful that you're doing, what your lines of code is. If it includes comments, and you're writing bonuses based on how people are writing code, maybe don't include comments, right? Or maybe you want better documentation and you do include comments. I don't know, right? That's, just know what you're actually measuring. Some of the classic problems I've run into in people, because we started building a central data repository for software development, some evil companies automatically go to, okay, how do I know who's our best programmer? You know, if I worked there for probably 2-3 weeks, I could tell you, right? The guys who are working there definitely know. I tell you what I can't do is it the guy who wrote the most code? Nope, probably not. Person who wrote the least code? It might be. You know, I think about 2 programmers I've dealt with. One of them wrote an entire C++ parser in 90 days by himself, okay? I'm talking at a sustained coding rate of 1,000 lines a day in C, not Java, not .NET, not big giant frameworks, and completely uncommented and undocumented. Beautiful prototype. Don't expect it to work anything other than the exact test case he used. Another guy, averaging something like 8 lines a day in assembly. Day in and day out, high performance code. Never fails, no bug reports, works in all cases. Who's the better guy? I don't even want to pit them that way. This one guy I use for prototypes, right? This other guy I use for high performance code. I don't know who the better programmer is. Is less better, is more better, is it maintainable? If you want to figure out who's good, you need to have a very complex metric that takes into account human assessment. Analyzing code maintainability. I'd like to bring out 2 words here because I've kind of thrown them about. I probably should move this slide earlier, but complicated versus complex. Complicated in the sense that code's difficult to understand. That's what I'm talking about. Complicated code isn't a good thing. It's not desirable. Sometimes you can't avoid it, but you should when you can, because we all know that code is going to live forever and somebody else is going to pick it up and change it. And that poor somebody might be you 5 years from now, and you'll go, what was I thinking? Okay? My brother, who wrote some of our original programs, when he touches an old piece of code, including his own person, he just deletes the method. Keeps the signature and deletes all the guts. He's like, I know I can write it better today. I'm not quite that crazy or confident, whatever you want to call it. He's a better programmer than I am. Maybe he's not crazy. Complexity is a number of interactions, and that's really what cyclomatic complexity means. It's talking about how many branches, how many possibilities that we have. Coupling is interesting because it talks about interdependence, right? So this module using that module, this function using that function, what's going on in here, what's using each other. Because if we find things overly dependent on each other, it's an indication of the spaghetti complexity, right? We've all heard spaghetti code's bad. There's no metric I'm aware of that actually has a one-to-one correlation with spaghetti, but it'd be cool if it did. And cohesion is how the modules belong together. Oh, this group together represents everything that we do for file handling, right? So good layout, good design. So these are some interesting, I think complexity in concert with coupling and cohesion give me a much better picture about what's going on, right? Because if I've got high complexity and high coupling, I probably do have a complicated problem, right? So very interesting thing to look at. Risk is another thing people try to use metrics for. Which piece of component or code is vulnerable? Not vulnerable might mean security, it might mean performance, it might be field failure, it doesn't really matter. And there's interesting ways to calculate risk, right? We can use static analysis. CWE is the common weakness enumeration. It's the way the government defines software vulnerabilities if you're not familiar with it. So you can look at and say, well, what weaknesses, not bugs, but what code do I have that has a susceptibility to a memory overflow, to a memory leak, to things like that. Unit test results. How are my tests passing? What kind of source control data do I have? Again, am I churning the code? Is it changing all the time? Does it get fixed and stay fixed? Does it get fixed and refixed and refixed and refixed, which might be an indication of complicated code? That's a very good, by itself again, probably false positive, but high complexity with code churn is a good indication of complicated code. Why did they fix it over and over? Because it's complicated. And the input from QA and manual testing. Manual testing means that people have to perform the test by hand. It doesn't mean you don't collect the data from the test. Okay? Okay, let me say, it should mean that you don't collect the data from the, all too frequently, it's manual testing happens over here, and they say okay, and we don't actually know what they did or how it worked. That shouldn't be. Another classic metric, am I on track? First thing you know, what does done mean? And it gets super deceptive. We did a continuous acceleration summit early last year with a bunch of different groups, Electric Cloud and such, about can I move my product and my team to continuous testing? And the first blocker people always run into is, I don't have a metric that tells me I'm done. Okay? So done is, have I finished all my requirements? Do I have a way to mark requirements I'm not going to finish? Am I marking requirements that I'm not going to finish? Do I have proper tests, proper coverage? Are they passing? Has the integration test occurred? All these things you have to figure out done before you can even think about, am I almost done? Okay, and I know it sounds difficult, but you have to do it. Normally you do this, you pick something, draw a line in the sand, say, well, I think done is blah, blah, blah. Measure it, try it, see if you're right. Right? You need to connect your requirements. If your requirements are over here and they're off in la la land and business people play with them and somebody converts them into whatever happens in our sprints, you won't know if you're done. Right? Because you're assuming, Stuart's favorite thing, that somehow all the requirements are properly represented in the work system. You need a connection to source control because you need to know what's actually being done, what got done, what didn't get done. And you need a connection to your development management data, right? How are my scrum schedule? What are people working on? When are they working on it? Things like that. Problem, where are the bugs? You know, it's funny because people do this less, but complexity was probably one of the, you know, Cyclomatic was one of the key offenders of this years ago. Back in the dark ages of software programming, when we used dinosaur languages like C and Fortran, okay, we had debuggers. The debuggers were really simple compared to what we have today. And the most common debugger was, and probably still is, like the print statement, okay? And so what happens, you had big, complicated programs that had like 100,000 lines of code in them. And a failure would happen in the field and you had no idea where it was. You went, where should I start locating? I can put the thing under debugger, but it'll take me a year to get through the program. So you were trying to look for tools that would help point you to where a bug might occur. And Thomas McCabe used to constantly promote, oh, McCabe will show you where the bugs are going to be and you can go look at these pieces of code. That's crap. There's no single metric that can tell you where the bugs are going to be. Now, today, we have things like runtime debugging, we have static analysis tools that will predict the probability of bugs and things like that. So static analysis is a great way to figure out where bugs might be hiding. Having more data, again, if I'm connected to bug tracking, if I'm connected to the source control system, I'm connected to the personnel system, I can say, hey, this file's got a lot of code churn, a lot of field bugs, the guy working on it's brand new to the team, okay? But probably problems. Testability by itself can show bugs. It's a very interesting thing. Anybody here use automated test generation? Couple. What I've found over the years, we sell a tool like this, and I've found that some code lends itself very well to automated test generation. Some code, not at all. And what I found is that there's a defining characteristic. Well-designed, well-architected code works very well. So it's funny, you might not care about automatically generated tests, but if you get a tool, get a demo, run it once, you get a low number like 30% or 40%, you probably have a complexity problem. So it's a very interesting cheat that you can use to analyze your code. And again, you know, making sure that you're connected to your bug tracking and your QA, that they're not silos producing information that no one actually consumes. Coverage metrics, we sort of alluded to it earlier, but we can leave it at the fact that there's a bunch of different ways people measure it, and people will like come to blows over what the right way is, right? And chasing coverage in and of itself is frequently not meaningful, right? You can have 100% line coverage and not have really scratched the surface.
Coming from the avionics side on this, for example, you have to make the independent effects of it going in, because you might go into the same line of code, but depending what the state of the machine is going into that line of code, makes a lot of difference.
Yeah.
So it's much more than just
So-
statement coverage.
I believe that you should be measuring coverage, but I don't believe that outside of compliance where you've got you're joint strike fighter and you've got to have 100% MCDC, then you do it, okay? But if you don't have a compliance requirement, measuring coverage is interesting, but simply improving coverage might not be your best bang for your buck. The bigger question is what's your problem and what's the right thing to do to address that problem. And technical debt, my last point I just want to make before we go into Q&A, this is as bad as complexity, and many of you probably are big technical debt fans, so feel free to throw your slings and arrows right now. Technical debt as a concept is a real thing. Debt is a real thing. We make decisions every day for our software that affect the future of our software. Okay? Sometimes we do it consciously. Oh, I don't have time to put that framework into place. Oh, security isn't going to matter to us today because it's only an internal tool, etc. It's conscious. Sometimes it's an accident. We didn't know any better. We didn't understand. We didn't understand that a memory overflow could lead to a SQL injection error. Okay? So it happens. Problem is, real debt isn't trivial to measure, and out there, the reason I bring this up is that there's a couple of vendors out there that sell tools that, A, measure technical debt. Okay, I don't know if they can tell me I used the wrong framework, or that I forgot to use security. And they tell you, how do you spot these snake oils, right? They tell you, okay, we measured your technical debt and it's 10,000 man hours. And if you buy our tool, we can fix it in 8. One of those numbers, or both, is wrong. Because if my debt actually is what they say it is, which I'm not agreeing, and they tell me it can be fixed in 8 hours, I have to argue that it's 8 hours of debt. Right? Debt that can be fixed in 8 hours is 8 hours of debt. Right? If I owe Stuart $1,000 and he's charging me 5% interest, I don't care that someone else will charge me 100% interest. His 5% is all that actually matters. So if someone can fix for you 8 hours of technical debt for $100, you might want to hand them that $100. But if they're charging you $100 times 10,000 because they're fixing 10,000, maybe it's not worth it. Technical debt isn't something you can run static analysis to calculate. I work for a static analysis company. I have for 20 plus years. It's what we do. It's our core. And I don't produce a technical debt number because I don't believe that what static analysis is doing has much correlation with debt that I care about, which is wrong framework, not scalable, it's going to have bad performance, it's going to be insecure. So watch out for the technical debt people. Believe in the concept, it's important, it's true, but handle it in peer review, handle it in design. Make a decision, make it consciously, knowing that you're going to pay later, and put it into the plan to pay it off before it kills you. So conclusions, avoid simple metrics for decision making. Make sure that the metric does what you think, and make sure that what you're doing to move that metric is actually going to move it. Questions? My happy question graphic. Yeah, David.
A lot of the metrics we're showing is what I call ratio type numbers, where there's quantity and you can add, multiply, divide. So some things are more ordinal, and there's some things that aren't quantitative at all. So how do you handle, like, well, customer happiness, for example?
That's a great
That's
question.
not even ordinal data, it's probably normative.
Yeah, so that's a very interesting one. It comes back to our can I measure quality? And the simple answer really is no. But the practical answer is, I got a pragmatic way that gets me in the ballpark. It's not a number I can compare to your number, but for me, I measure customer happiness based on adoption of new releases to existing customers in combination with the number of people bitching about the software, right? Because if people just aren't complaining, it doesn't necessarily mean they're happy. It means they're not unhappy, which is not the same thing. But if people quickly, when I give them something new, if they grab it and install it, it's an indication that they like the software more than, oh God, I've got this thing and it's working and I'm never installing an update. It's working, don't touch it. That's not an indication you love the software usually. So things like that, and you have to figure them out for each one. I don't believe the idea that you just accept that you can't measure it. I think that you should try to find something that isn't the single measure, but is an indicator. And I think you can find indicators. Just put them all together in a big graphic, and then you have your number. 7. On a scale of no one knows. Other questions?
I've always heard of coverage in terms of testing. Used in a different context and I'm familiar with it. When I hear coverage, our test cases, automated test cases will do 95% code coverage. But you had other ways to represent coverage or different meanings.
Sometimes coverage is related to tests. What lines did I cover when I test? Sometimes it's related to analysis, like when I did static analysis, did it cover everything? Sometimes it's related to requirements. Am I covering my requirements? So it's an indication that we've done all of something, right, when we correlate it with something else. When I look at test coverage, I expect to see 100% requirement coverage, that there's a test for each requirement. I also expect to see code coverage, that I actually tested the code that's there. And the funny thing is that 100% requirement coverage will probably never get you 100% code coverage, because the code's full of error conditions. The requirement probably doesn't state other than thou shalt handle error conditions.
The other part to that too is the assertion order. So it's also the sample location and analysis method. And a lot of the coverage tools only give you sample location, and you can throw in a search true in there, and it'll pass every time.
I think that if coverage is an important metric for you, that probably the best answer today is MCDC. I think it's the best we have. I don't think it's perfect, but I think it's the best we have.
MCDC?
Yeah.
I typically do it in, there's testing activity. We don't really know the quality of the assertions in there because we use JUnit and other things like that, so they don't report, Clover doesn't report the assertion. Just that there was activity there, but I typically use it in, but there should be activity over here.
And another great thing along that JUnit size, and we actually have some static analysis for unit tests that help you determine, and one of the classic things is no assertion.
Right.
Is a test without an assertion a test? I would have to argue that not really, right? And then we talked about this at lunch, right? To me, a test has two qualities, two properties. When it passes, it means something, and when it fails, it means something. In the absence of either of those, I'm in serious trouble. I should have at least one, hopefully two. Others? Thanks, everyone.
Thank you. Before you leave, please. Before you leave, please fill out your rating form. And again, Arthur, thank you very much for giving this very interesting talk. I will tell you that about 3 weeks ago, Linda gave a talk on metrics, changing from data to knowledge on my ASQ section. So it's very similar to what you're saying there. Metrics that have a meaning, you have to have actions based on the metrics that you're getting to. And if you don't have any actions to base on it, you might as well not take the data. So thank you again, everybody.
Thank you.
Yes, I am going to turn off the camera as soon as I get to it. I will make it to the camera sooner or later.
Stuart, would you get to the camera, please?